try to just establish some ground rules on naming organic compounds. We're not going to do all of it now. Of course, I can't do everything in 1 hour, but we'll try to put a foundation down so that that can help us to clarify some few issues. Okay. Okay, let's just get that out of the way. Yes, so can everybody hear me? Can all of you unmute yourselves? Make sure we're in a quiet place. Just give me a thumbs up if I'm clear enough. If you can all hear me. And also note that you can always make use of the chat box if you've got questions, comments, suggestions, whatever is not clear. All right, so guys, I'm gonna do the bigger part of it, like in questioning tomorrow during class when we meet in person. For those of you that are coming face to face, although I would encourage those that are in Windhoek that can make it face to face, because you've got handouts, and that really is helpful that you can answer these things. But of course, if you can't make it, it's also okay to be online. All right, so as I said, this first part is just going to be on nomenclature. Now, nomenclature basically means to name organic compounds. It's just a systematic way of naming organic compounds so that you can use the same name, that systematic or general name, all over the world. So whatever they're going to do in China, if they use the same name, we also use the same name here in in Africa. So if you look at some ingredients on medicine, especially tablets and so, you will find organic names on them. So most of the, just give me a second, my boys are making noise in the next room. Let me just get them quiet, just 2 seconds, all right? All right, I'm so sorry for that. This boys wants to bring their bikes into the office, but yeah. Anyhow, as I was saying, so basically we establish a general naming system for any organic compound. Doesn't matter what type of functional group it has. It has few basic steps that we need to follow. And then the specific parts are when depending on what kind of functional group they have. So my aim for tonight is to really look into the basics, okay? So the first slide that I have here is just some summary that we've just put together that is going to look at the naming of all the functional groups that we're going to deal with based on your curriculum. And then the second part is when we're going to go into the specifics. And then the third part, I have an app that we're going to look at that's going to give us a quiz, and then we're going to do that together. Whenever we have to zoom it in, we're going to take screenshots to make it as interactive as possible. So the app will help us to name, and it will also show us whether we are naming it correctly or whether we're not naming it correctly. I think I bought the app. I don't think it was very expensive, maybe $5-6 US or something. So you can just look at the app name, and on an iOS system, you can download it as well. It's a good practice type of app. But anyhow, let's jump into this. So as I said, the first part here that talks about nomenclature is just to explain to us, just put maybe my pen down on this side. So nomenclature is a system whereby we naming organic compounds. So that word just tells you that's how we name organic compounds. Now the IUPAC naming system, IUPAC stands for, who knows what IUPAC stands for, by the way? Anyone put up your hand if you think you know what don't Google it, just out of the head. Anyone know what IUPAC stands for?
So I can guess what the I stands for.
Okay, yes. Let's take a guess at each of the letters. Okay, let's start with you. What does the I stand for?
I think it's international.
Okay,
Me
there
too.
you go. It took the easiest one, huh? Okay, so the I is fine. Yes, it's correct. It's international. And the U, please don't Google
Union.
anything there.
I know the U is for union, and the C is for chemistry.
Okay, all right, yes. So we've got the I, we've got
And the P is
U,
program, I think.
Pure.
The one
no,
is
no, no.
pure and the one is
Oh,
applied.
yes. Pure is yes, and then we've got the applied. Okay, so what does it mean? International Union of Pure and Applied Chemistry, basically. So it is also just the main focus is that this system is used internationally. Okay, so the whole IUPAC naming is what we're going to use all over the world. All right, so
Sir, please
let us
check
just
the
look
waiting
at
room.
I don't see anyone in there. Oh, sorry. Let me scroll up. There are four learners in there. Thank you, Joshua. All right, I'm just admitting them to come. They will be in soon. All right, good. Thank you for that. All right, so this is not going to go in detail. So I actually took some text from a textbook. It's basically a first-year university textbook, which really is good. It's way better than the high school textbooks that we're using, and it's also easy to digest. We'll look at it in more specifics, but just generally, as we said, the IUPAC basically is a way of identifying that internationally. So it's a systematic method of naming organic compounds. Of course, we can also name inorganic compounds, okay? As it is recommended by the International Union of Pure and Applied Chemistry, okay? So pure is sometimes on the theoretical part of it and how that is then applied, all right? And of course, this is for big structures that we're looking at. So these are just official recommendations, but of course, we also have some common names. For example, vinegar is a common name for acetic acid. You understand? So if you have to name it as by this system, the IUPAC nomenclature, you would come to ethanoic acid, right? Because it has got that carbonyl group in it. So it's a carboxylic acid, but we can also know it as ethanoic acid or acetic acid or vinegar. So those are now the trivial names and the common names that we talk about. But when you are asked to name this in your exam, we want you to follow the naming system. Okay, so this is just to put just the background to this. And then what you're going to look at, the first functional group, and I'm not going to go in detail with this, is the alkane. So the alkane ending with the ANE are what we refer to as the single bonded carbon chains, okay? So which means that the carbon to carbon is single bonds only, all right? Now, that will create the basis of naming, and then everything else is built on this. And that is what we're going to focus on tonight, okay? So how are we going to find the longest chain? How are we going to find all the groups that are attached to the longest chain? How are we going to number these attachments to the longest chain, either from the nearest end and all the substituent groups that are there? How are we going to identify those locations and then finally assemble the name, alphabetic order? So all those nitty-gritties, we'll go through them. What I want to focus on or draw your attention to is mainly that we're going to look at alkanes, and then the next thing is going to be on alkenes, the ones that are ending with the ENE. That's also in your syllabus, although these ones, alkynes, are not in your syllabus. These are the triple bonds, but it's also worthwhile knowing. So we've got the single bond carbon-carbon, we've got now the double bond carbons, and we've got the triple bond carbon. Remember, carbon can take up to 4 bonds around that one atom. Are we following? Okay, so that's one way of looking at it, the single, the double, and the triple bonds. And then after that, we're going to look at naming your halides. Now, of course, we know that halides will be related to group what? Group what, guys? Halides will be related to group 7 because it is a derivative of the name of halogens, okay? So we're going to look at if you've got carbon-carbon change and you've got a group 7 element such as maybe fluorine, for example, or maybe even chlorine here. how is that name changing? Okay, so those will now be the substituents. Basically, that substituent means that you're going to take a hydrocarbon, carbon or hydrocarbon compound, and the hydrogen will then be replaced by a group 7 element. Are you following, guys? Okay, so we're also going to look at how we name that. And then we're going to look at naming alcohols. So those are now having functional groups which are
Apparently
ending
use
with
a darker
OH.
color.
Can I use a darker color? Okay. All right. So sorry, Charlotte, is the red fine? Or maybe we just try this. Okay. Is that better? Charlotte, thumbs up.
Yes.
Okay.
Yes, sir.
Right. So then we're going to look at alcohols as well. We might not get to that tonight. And then we're going to look finally at your carboxylic acids. This is now when we're talking about this group over here, which if you draw it properly will have a shape like this. And this side will now be attached to the rest of the carbon chain. Are you following? So this part here then compose that COOH. And then this means that it's attached to another carbon chain. And then the carboxylic acid also has a derivative. What does it mean if something is a derivative of something? It is derived from that. Are we together? And that derivative that we're talking about are now finally the ester, okay? So it's a carboxylic derivative, and then the ester is what we're going to look at. Are you following, guys? Now the ester has got the carbon with the oxygen and another oxygen here, and then the rest are connected to the carbon chain. Are we together? But specifically, this carbon chain that we're talking about is coming from the alcohol. So if you've got the alcohol part, and then you've got the carboxylic part, then we can then create an ester. Esters are normally in your fragments and your flavorants and things like that. Okay.
So,
JJ, your hand is up.
So I have a question relating to fat, sir. It's most an ester.
Yes.
But sir, it doesn't have a sweet smell as they say according to the text.
Because we've got fat in it, man. So for you to make that soap, right? You have fat in it. So that's why, but of course, that fat can also be flavored, like the shower gels we're using now, and the nice smelling Protect soaps and so on. Are we together?
Okay.
But it's an interesting thing that you're mentioning there, especially under materials. We'll look at how you can use glycerol and say basic, what is this, coconut oil with sodium hydroxide to make a soap, right? And you'll be able to see that structure as well. So guys, that is now in a nutshell what we want to look at, okay? Now let's go to the specifics, unless you've got some questions. Do we have any questions, or can I go to the specifics?
sir, I have a question.
Yes, I'm listening.
So for the esters,
Yes.
why they end with a what is this? An enol? Is it because of the alcohol?
Yes. That will normally be, when you are naming your esters, yeah, you would have it as your ethanoic acid, for example. Are we together? So in terms of the naming part, you can't really say the alcohol is shown in there. The alcohol you would normally identify with the presence of your hydroxyl group, your OH. Nah? So you can't
that's
really
just for the what is this? The alcohols that are being added to the essence to make the ester.
Yes.
Okay.
Now they help with the making up of the ester. The ester has two parts: the alcohol and also the carboxylic acid. So the carboxylic acid and the alcohol together will then make up the ester. That's now in a nutshell. But it's quite interesting. Once you start doing the reactions, then you'll see how it forms. The main thing is for you to be aware of the functional groups. Are you following? Okay. So I was just quickly getting the notes on this side. I have them here. So I'm just going to reshare my screen. I thought I had it open, but it wasn't open. So let's quickly share the screen, and then we can dive into the the specifics. Now, this is where I need your undivided attention, and people, please ask if something is not clear. Okay. So as I said, this is now from a textbook. I can also share the textbook with you. It's not very big. It's a textbook that will be very useful for you, especially if you go to university. Nowadays, with all these things online and soft copies, we don't really have to buy the textbook unless we prefer that. All right, so we're going to start with naming using your IUPAC rules, okay? So the rules help us to have a systematic name. So that's now, it doesn't matter wherever you are, you use the same thing. So the first thing that we need to establish is the parent chain. Now let us first understand, what do we mean with the parent chain? The parent chain is the longest carbon to carbon chain. Are you following, guys? Nothing else but carbon to carbon, okay? So if we are looking at this compound here, remember in the last class we told you that every part here represents a carbon. And then around that carbon, you would have your hydrogens. I hope that is clear, right? So if we had to identify the longest chain, this was the longest chain. Now I'm going to zoom in a little bit to show you what we mean with that, okay? So we will start counting the carbons. So we have carbon 1, carbon 2, carbon 3, carbon 4, 5, 6, 7, 8, 9. So that is the longest chain that we have. Even if you try to look at other carbon chains, let's try to say maybe you are starting from here, 1, 2, 3, 4. That green one was only having 4. Maybe we could have another blue one, or maybe 1, 2, 3, 4, 5, 6, 7, 8. Only 8. Are you following? If you had to go 2, 3, 4, 5, 6, if you had to go 2, 3, 4, 5, 6, 7, 8, the 9 is the longest one. So the first thing that you need to establish whenever you are naming or using this IUPAC name is to identify the parent chain. The parent chain being the longest carbon to carbon chain. Okay, are we all together? Thumbs up if that is clear. If it's not clear, please just let me know. Is it fine? Okay, I think that's the easiest part, isn't it?
So
Yes, sir.
Okay, great. Okay, great. I can see that's good. So now for you to name, yes, your question.
So this is what I always forget doing. So when it comes to naming, I forget to check the longest chain.
Yes, and once you have missed that, then the whole compound is wrong. So that's the very first thing that you need to, and that's the thing that you need to master. Now, that parent chain, like in this case, we have identified that that's the parent chain that is highlighted or been bolded with a red pathway there. Now, for you to name it, you need now to know the parent names of alkanes, okay? So if it's only one carbon, it would be mid. If it's 2 carbons, it would be eth. If it's 3 prop, 4, and it will go on like that. Now we said we have sort of like a short sentence that will help us to understand the first 4. Who remembers that sentence we used?
Monkeys eat peeled bananas.
Perfect, perfect. So the M there we could say is monkeys, and then we've got eat peeled bananas. Are we together? So we could put it like that so that you can remember based on your MEPB, especially with the prop and the but, that could cause a confusion. Which one is 3? Which one is 4? All right. And you are expected to know the first 10. Are we following? Now, this same parent chain applies for all the functional groups, okay? For all the carbon to carbon. The only thing that will change here is the last 3 letters. Like you can see, all of this are ending with an ANE, 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 meaning that these are all alkanes, meaning that they are all single bonds only. Does that make sense? Okay. And of course, what we have over here is to go on here 11 up to 20, then from there 30, 40, 50, and then 100. You do not need to know this part, okay? It's not expected, but it's good just for interest sake to see how they name them if they go very far. Right, good. So that's the first part. Yes.
Like between that 50 and the 100, there's still like more names. or more
Yes, of
carbon
course,
atoms?
of course. These are now just in the tens that they are showing. Of course, 51 would have a different name. 52 would have a different name. 53. Yeah, but you don't worry about it. You don't need to know all of that. You need just to know the first 10. That's it.
Yes,
And it's also easier, especially from 5. Pen because of the pentagon, hex because of a hexagon, heptagon, octagon, nonagon, decagon. You remember those polygons, regular
yes,
polygons
sir.
in mathematics. So that's one way that you can look at it. So the first 10, I think, are straightforward. Are we following? Okay. All right, guys. Now, with that now in mind, if we go on further, I just want to show you some mistakes that we make in identifying the parent chain, okay? So if there is competition between two chains, meaning that they are both equal in length, there's none longer than the other one, right? Then the next step is for us to look at the substituents. What are substituents? Those that replace the branches of your hydrogens. Now let's zoom into this and let's quickly look at this. If you look at this parent chain, without really focusing on the numbering of it, okay? Actually, if we have to number it, we have to number from this side. 1, 2, 3, 4, 5, 6, 7. The same applies over here, all right? So if I say 1, 2, 3, 4, 5, 6, 7. So they both have a parent chain of 7. So which means there's competition. So now we need something else to determine which one will be favored. Are you following, guys? Okay. Thumbs up if you understand what I'm trying to say.
So you have to take the one that are having less substituents.
The one with the more substituents.
Oh.
The correct one will be with the more substituents. This has got 3 substituents compared to the one that with 2 substituents. Are you following? Okay, so you will choose the branch with the more substituents. So this would now be the correct one. So you try to identify your parent chain in such a way that it has got more substituents, more added to the parent chain. Does that make sense? Okay. So what did we get now? Parent chain. If there's competition, we look at the one with the more substituents. We'll go into naming the substituents. So those are the first points that I want to highlight. Are we having any questions? Okay. If there are no questions, let's quickly look at this one without looking at the solution at the bottom. Let us identify, sorry, let's just get the pen out. Let us identify the parent chain in this compound. Okay, so let me zoom it in. I hope it's clear for all of you. Just by first glance, this looks like the longest chain, isn't it?
Yes, sir.
Are you agreeing?
Yes, sir.
So I could start and then I start counting and say, okay, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 carbons there. Right? What about if I count? Let's take a different color. Let's take red. What if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10? Do you see that? If I take this as my parent chain, this is my parent chain. So JJ, as you said, sometimes we make the mistake. We try to count and try to count all of them, the ones that look the longest. So now, if we let me just mute you there. Mauritius, there's a bit of background noise there. So if you have identified that that's probably the longest one, the first criteria is the longest one. If you happen to find a case that you've got 2 that are equal in length and that there's competition between them, then we go to the second criteria as to see which one is more having more substituents on it. So if you look at this red one, how many substituents do you see on it?
So is it not just
2?
2 because of this one here and this whole one, right? So we counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The blue one was 1, 2, 3, 4, 5, 6, 7, 8. Is it what? Let me just recount. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is there another one that could probably give us 10? 1, 2, 3, 4, 5, 6, 7, 8. I don't see anyone. 1, 2, 3, 4, 5, 6, 7, 8. Are we together? So if we go to this, we will then see if we, let me just clear it because it's getting a little bit messy. Can we count another one?
Yes, sir.
Yes, we.
We were okay.
This-
We could look at this one. Let me just get the
Correct.
pen. We could look at this one here, isn't it?
Yes.
Mm-hmm.
How many do I have? 1, 2, 3, 4, 5,
10.
6,
10.
7, 8, 9, 10. Which means that 10 is also equal to this one, the red one. Do you understand? But what is the difference between this? The red one has
It is
got only 2 substituents, this one and this substituent, isn't it? Are you seeing
Yes,
what
sir.
we mean with the substituents? Let me try to clear so that you can see what we mean. If we have identified the parent chain, maybe to be this red one, okay? What is attached to that parent chain? That's what we mean with the substituent. There's an attachment over here, which is this whole thing over here. And then there's an attachment over here, which is this whole thing over here. So we've got 1, 2 attachments. Those are the substituents. Is that making sense, guys?
Yes, sir.
Okay. All
Yes,
right.
sir.
So let us then look at the
Yes, sir.
other one now. All right. Now the other one was now, let's make that one blue, I mean green. So we had, all right, it's still red, but let me try to make it blue. So this one is also having 10. Are you following, guys? Okay.
Yes, sir.
So in those 10, how many substituents do we see? There's an
4.
attachment over here. There's an attachment over here, attachment. So it has got 4. Pardon? Okay, so we've got 4 over there. So which means that this will now take preference. Are you following, guys? So if we look at it, that's the solution that we have. This will be the correct one. This will be the wrong one. Are you following? Because I've got 4 substituents here. On the other one, I only have 2 substituents. I hope that is clear. Does it make sense, guys?
Yes, sir.
Okay.
Yes, sir.
Now the next part, just as an exercise, we can just quickly do that together as well, okay? So in this exercise, identify and name the parent chain of the following compound. Here, they just expect us to name the parent chains, okay? In the chat box, just give me the parent chain here. Just by looking at it, I think it's, just visualize it. How many carbons do you see on the parent chain? Let's see who can get it first. Just in the chat box. Okay, yep, thank you, Rosta, for that. I can see 6. So I've got this 1, 2, 3, 4, 5, 6. Those are my carbons. 1, 2, 3, 4, 5, 6. Are we together? So what will the name be? The parent chain.
So is it not hexane?
Same.
Yes, so it will be hexane. This emphasizes that it only has single bonds. Are you following, guys? Okay.
Yes,
Is
sir.
that making sense? What about this one? B. Let's say we try to take this as our parent chain. So we've got 1, 2, 3, 4, 5, 6, 7. Are we together? All right. Is there anything else that can beat 7? Let's try from this side. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It looks like 7 is the main one, isn't it?
Yes, sir.
So then it will be
Heptane.
Heptane.
Perfect. Right. What about this one? Looks like this is the parent chain. 1, 2, 3, 4, 5, 6, 7. That
Heptane.
also the same. And then you've got 2 substituents on it. We'll get to the substituents in a while. Let's look at this one. How many do you see is the parent chain? We could maybe at first glance go for that one. So we'll have 1, 2, 3, 4, 5, 6, 7, 8. What if we went for this part from here? How many are there?
The same,
1, 2,
sir.
3, 4,
The
5,
same.
6, 7, 8.
Same.
Okay. Which one will we prefer? The green? Does it really matter?
No.
Either one has
No,
only
it doesn't.
No,
one
sir.
substituent.
Either one has one substituent.
Exactly. So 1, 2, 3, 4, 1, 2, 3, 4. They actually have the identical substituents, so it doesn't matter on that. And then we said the parent chain will be 1, 2, 3, 4, 5, 6, 7, 8. So it will be octane. Are we together?
Yes, sir.
Is that clear? All right, perfect. So that's what we have. Now, just to recap, we looked at two things. The one part was to look into the parent chain and also if there's competition, the number of substituents. Now let's name the substituents. Of course, guys, you've got your halogens that you can also have, but we're looking at substituents that are only having carbons and hydrogens in them. So if we have identified, look at this is our parent chain, okay? So that's why we would say that this is the parent. And then we've got this first substituent, the second and the third. That's why we say these are the substituents. Now, each one of them, if I zoom in, you would see that it is attached to the main parent chain. Maybe I should have used a different color there. Let's try to just maybe use a different color, maybe the red. So they are attached to the main one. They are attached to the main one. They are attached to the main one. But what I want to bring your attention to is count the number of carbons you have in that attached one without including the carbon in the main chain because it was already counted in the main chain. How many carbons do you see in the first substituent without this carbon?
2.
1, 2, right? So you've got 2 carbons there. All right, 2 carbons. And here for number 2, 1, 2, 3 carbons, right? So we've got 3 carbons. And for this one, we only have 1 carbon. Now they will be named based on the number of carbons they have, and they will end with a name. You know, of course, when it's 1, we say monkey, right? So we have that. But instead of having that, it will end with a YL. It's almost like to say it's deprived with 1 carbon. Are we following? I mean, 1 hydrogen rather. That is when it's only 1 carbon. If it's 2 carbons, we will say this will be an ethyl, right? If it's 3 carbons, we would say that this will be a propyl. If it's 4,
Propyl.
yes, it will go like that. Are you following, guys? And those ones that we have are known as our alkyl groups. Are you following? So I just want to explain what I mean with an alkyl group. So a methane, if you have a methane, it will be CH4. The fact that it has 1 carbon means that it is meth, and then it's single bonds only, that it means it's that case, right? Now, a methyl, if it's an alkyl group, that means it will be short of 1 hydrogen, that you'll have something like this. So that extra bond is ready to mingle or attach to a parent chain. So there's always that extra that will attach to the parent chain. So if it's only 1 carbon, you would say methyl. If you had 2 carbons, for example, this is what you'll have for a, what is this? Your normal ethane. Let me put it this way. You'll have your 2 carbons. This will have 3. And then this will also have, how many carbons will you have here? Also 3. Are you following? Now, if it becomes an ethyl, it will be, what will happen here? It will only be 2 carbons. Are we following? The rest here, and then this will be 3 carbons. There's 1 hydrogen short. Are we following? Not carbons, but hydrogens rather. So this will now be from ethane to ethyl. So when we have to look at this, let us just quickly clear this. What will you name the alkyl groups that we have here? If we go back and we number them again, so we said this is our first one, this one here would be our second one, and this would be our third one. What will the first one's name be? Look at the carbons, 1, 2. So you'll name it as, yes, Kakuire? Yeah, okay. What about the second one? 1, 2, 3 would then be? Monkeys eat peeled. Yes, so it will be propyl, always ending with a YL. And then this one, number 3, would just be methyl. Yes, Mauritius?
Can you explain the naming thing again, please?
For the substituents.
Yes.
We only count the carbons that are not attached to the parent chain. So this 1, 2, 3, because there are 3 of them, we've got the prop. Are we together? And because it's an alkyl group, it will end with a YL. Because we only have 2 of them, it will end with, it will be with the eth, right? If we only have 1 carbon here, it will be meth. Just like we had your methane, your ethane, your propane, your butane, you remember that? So the naming in terms of the number of carbons still remains the same. The only thing we do is just to have the YL, YL for the substituents that are your alkyl groups. Does that make sense? Okay, is it clear?
Yes, sir.
Okay, now with that said, the rest of it just shows us that, okay, we have our, what do we have here? We said this was our ethyl, our propyl, our methyl. So what did we do so far? Parent chain, if there's competition in terms of the length, we look at the number of substituents, the one with the highest will be favored. Number 3 is now to know how we will name the hydrocarbon substituents, which means they are strictly only consisting of carbons and hydrogens only. When you're counting the number of carbons on the substituent, especially for your alkyl groups, then you will only count the carbons that are not attached to the main parent chain. Does it make sense, guys? Are we together?
Yes, sir.
Okay, I'll share these notes with you after the lesson, okay? All right, so then we've got the alkyl group over there, right? So this is just to explain that those ones that are now called your methyls, your ethyls, or your propyls, ending with a YL are known as your alkyl groups. Okay, so that's the third part of it. So then we move on. Now we're gonna see how we're gonna put this systematic name together, right? Yes.
On the structures there,
Mm-hmm.
they show you there's a double bond and they show you how a single bond looks like. Now, there's a question paper I saw, if I'm not wrong, there's a line where it was in bold, but it was just a single line. And there was another one which was not in bold. Is there a difference between those two?
Maybe they were trying to highlight the question on which carbon they are talking about. Are they talking about the middle carbon, the terminal carbon? So the boldness could have just referred to as to where the emphasis was. Maybe that is where the reaction was taking place. Maybe the hydrogen on that carbon was being replaced by, say, a halide, or you understand, a halogen or so. So in terms of you seeing double bonds or a bold single bond, do not confuse a bold one as a double bond. As long as you don't see 2 lines there, it remains a single bond. Is that clear? Okay.
Yes, sir.
Good. So the boldness doesn't add it to that. So this table here just shows you your alkyl groups. Again, 1 for the meth, 2 for the eth, 3, and it goes on like that. Now, all of them will end with a YL, 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 and it goes on like that. Okay, are we all together, guys? Right. So now that we know this, we're going to try to put the name together, slowly getting to the complete name. So let's go to the next one, okay? Now we're going to assemble that systematic name for the alkane. Remember, guys, this basics that we're doing for the alkane name is applicable to the rest of the other functional groups, your alcohol, your alkenes, your carboxylic, and everything else. Are we following? It's just that with the functional group, there will be a little bit of a difference. So let us see how we do this, okay? Look at this 2 here. We've got a parent chain of 5 carbons, which is the longest one, all right? So if this is my parent chain, okay, let's just use the different color, then this is the substituent on that parent chain. Are you following, guys? And then the same applies here. If this is my parent chain with the 5 carbons, that means that this is now my substituent. And we know that is methyl because it only has one carbon. We count the carbon that is not attached to the chain, the main chain, okay? Now, when we name it, we give it a number here, right? This number indicates on which carbon it is connected. It is connected to the second carbon, right? In this case, it is connected to the third carbon. Are you following, guys? Now remember, if I count from this side, or if I started counting from this side, it will still be the third carbon. So then if you want to make this a specific name, we would now say 2-methyl pentane. Pen because there are 5 carbons, tane because there's only single bonds. And then you've got the same over here. Now, if you look at these two structures, I can say the first one or the second one, they've got the same number of carbons. They've got the same number of hydrogens around it. They've got the same substituent on it. So this is what we will name as our isomers, right? Constitutional isomers, your positional isomers, those are things that I want to look into tomorrow, which means that if you have to put down the chemical formula for this, right? Let's say you count all the number of carbons that you have in both systems. Let us quickly count all the carbons that we have, okay? Without really focusing on the structural formula. So I've got 1, 2, 3, 4, 5 carbons, right? In the parent chain plus this one. That means I've got 6 carbons here. Are you following? Okay. And then let's look at the hydrogens. I've got 1, 2, 3 hydrogens there, 1, 2, 3 hydrogens there, because this carbon has got 1 and then the 3 to make it 4. This carbon has got 2, 2. This one will have how many? The one carbon here would have 3, and this one will have only 1 carbon. I mean 1 hydrogen. So I've got 3 plus this 3, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I'll have hydrogens that are 14. So that formula would be C6H14. The same for this one. I'll also get C6H14. So if they are structural isomers, the condensed formula is the same. They are just different in structure. This is connected to the third carbon for the substituent. This is connected to the second carbon. Does it make sense, guys? I'm just trying to lay some foundation down tonight so that tomorrow it will be a little bit easier. Is that correct?
Yes, sir.
Okay, so we know what we mean when we talk about isomers, okay? Constitutional, structural, we'll explain the difference between them tomorrow. But that's just something to be aware of, okay? So the next thing I want...
You were saying... Sir?
I'm saying that if you look at the structure of this and the structure of this, we can clearly see that they are attached to different carbons, right? Now, in terms of the structure, they're different, but both of them, if you look at the chemical formula of it, both will have your 6 carbons and your 14 hydrogens. Does that make sense? So they've got the same amount of carbons and hydrogens, although they are not the same in structure. You know what an isomer is, right? They've got the same proton number, but they have different mass numbers. So structures are different, but then the overall compound is the same. So if you get the mass of it, if you calculate how many carbons you have here, give me the molecular mass of this, you'll say 6 times the 12, and then you'll say 14 times the 1, you'll get the same mass. Are you together? Although they are different in structure. I'm just showing you structural isomers, what they mean with that. Is that clear?
But sir, what I was asking is, you were saying the 2-methyl pentane, if you were counting from the left-hand side, so that means it's on the second carbon. But what if I want to count from the right-hand side, then what? Then would it be on the... That is a
very important question, and that brings us to the next point. That is exactly what we're trying to discuss here, okay? So, just as you said, what if I count, or you count from left to right, and someone else counts from right to left? Are we together? Now, we have only one substituent on both sides. So you count from the side where the substituent is on the lowest carbon value, which means you count from the side where it's the closest to the substituent. Are you following? So if you count from this side, it will be the closest to this side, right? All right, so that's the correct way. If you count from this side, you will be on carbon 6, which is incorrect. So instead of putting 6-methyl, and then you put now your heptane, you would now put 2-methyl, and then your heptane. Are you following? You want to keep it as simple as possible. You don't want to complicate with the numbering. Does that make sense?
Yes, sir.
Okay, so everything I'm saying here is been explained in all these explanations I'm having here. But let's get back to this. Will it matter whether I count from the right or to the from left to right here, or from right to left? I will still end up at number 3. If I had 1, 2, it will still be 3. 1, 2, 3. So therefore, it doesn't matter whether I go from left to right or right to left. Do you understand? So that name will remain the same. However, for this one, it matters, because if I go from left to right, I'll be on carbon 2. But if I go from right to left, I'll be on 1, 2, 3, carbon 4, which means the 4 is too complicated. We want to keep it simple. The 2 will take preference. Does it make sense?
Yes, sir.
Okay, perfect. All right, so we will have that. So this is just telling you, if one substituent is present, it should be assigned to the lower possible number. In this example, we place the number here on carbon 2 instead of carbon 6. Are you following? Okay, now sometimes it's not so straightforward. Sometimes you would have things like this. Now, when you have multiple substituents, more than one substituents are present in that, like in this case, let's look at this 2 here, okay? So we've got one substituent on carbon 2, and then you've got 2 substituents on carbon 5. Here we've got 1 substituent on carbon 6 and 2 on carbon 3. If you are counting from right to left, and here you're counting from left to right, and here is from right to left. Now, we would say this is correct simply because if you look at, you remember, by the way, whilst we are here, since we've got 2 substituents on 5, you'll put it twice. Since we've got 2 substituents on 3, we put it twice. Now, if you look at this 2, 5, 5 compared to 3, 3, 6, you are trying to take the one that gives you the lowest sum. Like 2 plus 5 plus 5 will give you a total of 12. Whereas 3 plus 3 plus 6 will give you a total of how much? Also 12.
Right.
Now, if you look at the values here, you look at the values where you have the lowest one. So that's why I say sometimes some people use this, but I defy that. Where do you have the lowest set of numbers? 255, right? Compared to 336. So what will happen here is, if you read this, is in the following case down here, the parent chain substituents are on the 2, carbon 2 and carbon 5, 5, there are 2 of them. Okay, and rather than this, because we want the first locant, the first substituent, to be as low as possible. So instead of having the first one at 3, we want it at 5. I mean, sorry, at 2. Does it make sense, guys? Are we all together? It's extremely quiet here.
Yes, sir.
Yes, sir.
Okay, good.
Yes, sir.
So you want your first
Yes,
one,
sir.
you want, good stuff, thank you. You want your first one here to be low as possible. Are you following? Okay. Now we go to the next one. What if it's a tie? What if both first ones are 2, 2? Then you look at the next value. Then you want the next one to be as low as possible. 3 will beat 5. If it happens that they were also in a tie, then you look at the next value. Does it make sense, guys? So the second locant, where is the second location of your substituent? That is basically what that term means, okay? So if there's a tie for the first one, then you eliminate that, then you look at the second one. Again, you take the lowest one. Are you following? Is that making sense, guys?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So now, if that is the case, like you see how we have named this. We have named this in the following way. The first one for your ethyl was 4 here, which beats the 5. Are you following? Are we together?
Sir.
Now,
Yes, sir.
when we are putting the substituents here, we try to put them in alphabetic order, which means E comes before M alphabetically. Are you following? So that
Yes,
will
sir.
take priority. Are you following? Okay. So even if you had one like the propyl, you will see where is P compared to M or compared to E. So if you have this type of situation, then you would now look at the lowest number that is assigned alphabetically. So the alphabetically, which one, of course, when you name it, you need to put the E before the M. Therefore, you'll take the E that has the lowest number. Although the M here has a lower number as compared to the 5 here. So please take this. And these are some of the things that are omitted from your high school textbooks. That's why I opt to use this, so that you can thoroughly understand how to name this. Okay, Moses, your hand is up. You've got a question.
Yes. Yes, sir. So it's not naming depending on the number of carbons. It's just like it's just alphabetical order.
Yeah. It is especially for your substituent. Remember, this name is not complete. Can you see that?
Yes, sir.
This is just strictly focusing on the positions where they are located, your substituents. If you have to complete this, you still have to add the octane on both sides. Are you together?
Yes,
Because your
yes, sir.
parent chain has got 8 there. So this naming just tells you which one will take preference. So if you have E before M or M before P, what I mean with that is now your ethyl, your methyl, or your propyl. But remember,
Yes,
what about your butyl? Butyl will be the first because B is before E, and then M, then P. Do you understand? So the
yes,
preference will be taken by the alphabetic order. That's what we're trying to say.
okay, sir.
Are we together? All right.
Yes, sir.
I hope that is clear. So we're almost done, guys. We're almost done with just putting this down here. Guys, I want to make sure that you thoroughly understand what we're doing. Okay. So this example here is just for us to name this compound here. Okay. So what we're doing here is, again, we identify the parent chain. So this is the compound that we're looking at. So the parent chain was this one, which was now the longest, consisting of 2, 3, 4, 5, 6, 7, 8 carbons. Are we together? Which has got 3 substituents to it. Now look at this. Where will you start numbering? The one that is the closest one, right? So you will first start with the second one, right? Because if you were looking at the ethyl, that would be 1, 2, 3, 4. Or from this side, 1, 2, 3, 4, 5. So you start with the one with the lowest. Are you following, guys? Okay. And then this will now be on your 3 of that. And then this will now be on 1, 2, 3, 4 of that. Does that make sense? Are you following,
Yes,
guys?
sir. Yes, sir.
So when you are naming, look at what happens here. I put the E first before the M. Now the prefix that I have here, like di, means I've got 2 of the same one. I've got 2 methyls. That's why I've got di. If I had another methyl maybe over here, then I would have tri. Now those prefix as your di, your tri, we do not take those as alphabetic order. We take the alkyl groups as your alphabetic order. Are you following? Does it make sense? And this was named based on the one that is closest to your numbering, should be the closest to this side. If you had to number from this side, you will now be on 1, 2, 3, 4, 5, carbon 5, carbon 6, and carbon 7. Now compare that now to, you see carbon 5, carbon 6, carbon 7. That is way more than the 4, 3, 2. Does that make sense, guys? So this is just explaining that if you're looking for the alphabetic order, we're looking at the E and the M. This prefix here as your di is excluded. It is not considered. Does it make sense? Okay.
Yes, sir.
So again,
Yes, sir.
you can go through the steps here again, the steps: identify the parent chain, identify the number or name the substituents, and then assign your locants, that's just your location of your substituents, and then arrange the substituents alphabetically. Those are the basic steps we are following, okay? So we are almost done. The next part is just to summarize them. Okay, everything we've done so far. Identify the parent chain, okay? Let me just, sorry, I need to get my pen out. Right, the summary here. Identify the parent chain, and then find your alkyl substituents that only has your carbons and hydrogens connected to the parent chain, and then name the substituents using the name from that table that we had. Is it your methyl? Is it your ethyl? Is it your, all of that? All right, and then identify more complex substituents. I'm gonna just put a star here. These are now branched ones. Nah? It's not really, it's just for interest's sake. I've never seen in your exam papers that they've asked those ones. Nah? But in case, I will not, if you are interested, I can explain this to you later if you are, no, Kakura, I can't really hear you. The last time you spoke, you were too far, right? And then finally, after all those steps, you start assembling your systematic name. Based on everything, then we'd come to the conclusion like that. You've got the 3 substituents, you have it like that. Right, guys, so that is now the thorough explanation on alkanes. The alkenes,
So you cut out. Sir.
Right.
Essa classe é Cláudia. Estás pronto?
all right, sorry guys, sorry. I think my meeting was just for an hour, so I don't know whether Zoom locked me out or whatsoever. But anyhow, I would just like to wrap up because it's been really a long day, especially for you that have been in all 3 lessons, for some of the learners. So once we understand this is what I want to do. There's that app that I was telling you about. It's called Nomenclature. There's Nomenclature 1 and 2. So for example, guys, do I have your attention? Just thumbs up.
Yes, sir.
So that you can see
Yes,
what
sir.
we're doing, okay?
Yes,
so this
sir.
is
So you are gone again. I cannot hear you.
It's miskien die
structure
netwerk.
there. Okay. Oh, sorry, guys. I did not share my screen. Oh, it's a. I'm just talking here and. Thank you, Moses. Now the rest of you are just quiet as if you are seeing everything, huh?
Meneer, ons kan nie vir meneer gehoor het.
Okay. All right. No. That was I'm saying this is what the app looks like. Okay. So what I'm saying is, you see here on the left-hand side, far left, you've got all the different functional groups. And then here, since we're dealing with alkanes, just the general structures in terms of the number of carbons, up to 10 carbons. Then you start off by identifying the parent chain. Then you would say, okay, They say, where is the parent chain? Then you can identify the parent chain. Then you tap to reveal your answer. So they show you, here is the parent chain, okay? 1, 2, 3, 4, 5, 6 carbons. And then you've got 3 substituents there. How will you number this? Will you number from the left to right or from the right to left, and why?
Stays from
the left to right.
left to right.
Because your first locant is the closest to that side, right?
Yes, sir.
Yes, sir.
So in other words, if you do that, then we'll have something like this. Let me just quickly take a screenshot and then zoom it in. So if we do that, then we'll have something like this, okay? So we'll now number them 1, 2, 3, 4, 5, 6. So I've got this over here on carbon 3 and carbon 4. What will the name be here? 2 bracket 3 bracket 4 and then dash
methyl.
Trimethyl.
Methyl, and then how many? Hexane. Isn't it?
Hexane.
Now what I want you to do, what I want you to notice is how you separate between numbers are with commas. How you separate between numbers and letters are with a dash. And then you can start with your tri, your prefix, and then between your substituent over here, and then your, just hold on, Ms. Mugunda, this is since it's over time now. I will just conclude now, Ms. Mugunda. Right, so we've got now your hexane. Then there's no space. The boss is calling, guys. What are you laughing at? Before I get into trouble. So we've got the parent chain like this, okay? So if I go back to that, this is what we have. So what the app does is after you identify the parent chain, they can even show you how they number it, man. Because the first part is just to get the parent chain. Just helps you to identify the parent chain. This, you know, all of these exercises here just to do the parent chain. After that, we'll start now to number them to see. So when you take the quiz, for example, you'll have something like this. So that's the chain. So now they will ask you now, okay, 1, 2, 3, 4, 5 is our parent chain. Eh? 1, 2, 3, 4, 4, not 5. Eh? 2, 3, 4. So now you can change the parent chain here to say, okay, I'm going to change it. What is my parent chain going to be? Monkeys eat peeled bananas, isn't it? So will it be this or will it be that?
Butane.
Butane. Yes. So that will now be my parent chain. Okay. So then I can say I'm done with the parent chain. And then I add my substituent. What am I adding there? Is it a methyl? Is it a double methyl? Is it branch? We don't do the branch yet, but I can explain that. All right. And on which carbon is it? Then we can move up here. So I've got that. And then it is on carbon 2, for example. Then I say I'm done. Are we done naming it? Can you see the name there? 2-methylbutane?
Yes, sir.
Then we submit and check. Wow, we are correct. We got 3 out of 3 for that question. Is this not fun, guys? For us to keep ourselves busy with this, then to watch our WhatsApp status and all those things. Huh?
TikTok.
And TikToks and all that. So you can go on like that. For example, who can help us with this? What's the parent chain? 1, 2, 3, 4, 5, 6, isn't it?
Yes, sir.
So we will say the parent chain would now be 6. So we'll have the hex. We submit that. What about the substituent? There are 2 of them, isn't it? Di. And then they are both on what?
On 2.
Both on 2.
On 2. So then we would say, okay, we've got now on 2 for that. And then we would say for this one, I also have it on 2. Then we'll say, okay, we are now done with that. Are we ready to submit? Are you confident?
Yes, sir.
Yes.
And we submit. Voila, 3 out of 3. Are we together? So let's say on the next one, maybe we just try to make it wrong. Maybe we just take a random one. We say it's 6, and then we add something like this. We just put this. I'll be with you now. We submit. You see that it's wrong. 0 out of 3. So they'll tell you where you score your marks, maybe on your substituents and so on. Yes.
Even send with the emoji. Meneer, ik wil
Ja,
zeggen,
nee.
kan meneer kan meneer alsjeblieft die link voor die ding sturen?
Let me check. I think it's just nomenclature. Just go on your app store and you just go and type that. So let's quickly check. So you just go on the app store. I think Android might also have that. So you say.
No, meneer wil zeggen, gebruik Android of wat?
No, ik ken maar. Jy kan die iPhone is mos kom jy nie jou naam skryf nie. Jy skryf net iPhone daar. Yeah, you see there it is. The first two, I think they only have 1 and 2. Because I already have it, it will just say open. I think it costs something. I'm not too sure. Let's try to just go into it. I think I paid something for it. Or is it free?
Kom ek op
I'm
je
not
phone.
too sure.
Yes, sir, you have to pay for
Yeah, it's $2 US. Yeah. $2 is just $30, man. It's not a lot of money. $40.
It is
I mean,
bad.
it's less than $40. You understand? Reaction. Okay, you see the one I haven't bought now. You see, they made new ones now. So there's the one for the reaction. So you can just put it on there and then you can purchase it and then you can put in your Apple ID, blah, blah, blah. And then, yep, you can purchase it there. Right.
No,
So
meneer,
I
is
see
it not
this.
for organic chemistry?
No. I mean, you know, the thing is, also apps, so must not they fun apps. You must also go to educational apps, guys. There's a lot of things on this thing.
No,
So you can
I'm
always
asking
go
now.
and search for physics as well and so on. You're doing
I'm
what?
asking now for the nomenclature or what's the thing? Is that
The
for organic?
No. You can also go and say nomenclature inorganic, for example. But you don't do inorganic at school, only at AS level. So there's chemical substances quizzes are there for inorganic. I
Yes,
remember,
yes.
you know, I downloaded a few things. I think I
Ik
put
vraag
a
in die
folder.
app.
No, the app is just strictly on organic. You can go, I have one on nuclear physics.
Als ik
So
moet al
you can
die
go and,
scope beter.
you see now,
Yes.
when Mr. Simba was explaining to you what happens here, as they are going, they can go up, they can go down, they can go straight. Which ones are the gamma? What happens if you introduce a magnetic field to it? So this is a nice visual stuff. I want to one day develop this type of content and maybe make apps. Ims, do you hear me there? You that likes to make your things, huh? All right. JJ, I think the book I'm using, because I try to take a lot of different sources, and that's good, especially if you go in research, man. Let me just stop sharing that. The book I'm using, I think it's Organic Chemistry by, I remember when I was at school, and that's the thing, man. Let me see, I still have my Organic Chemistry textbook. When I was at university, we were using, let me just try to find it here in the cupboard. We were using, I don't know whether this thing of mine is still working.
Says those books that don't have pictures.
No. Hi, Mauritius. Let me see if I can just find, let me just switch on my video here. You see this one here?
Hey.
Salmons.
Oh, that book here.
Yes, this book here. So this was now my organic. You see how old it is. When I was doing my B science, you see, it's still having those plucky keys and what. So I never sell my books. I try to keep them. So yeah, so this was what 8th edition, like you can see
1986.
here. Now it's no, man, I'm not so old. I was born 1987, man.
Ik praat van beter setira.
Oh, meneer Natok.
Relay.
You must look at the book, man. What are you looking at? Es me slap clear, es me slap clear. Okay, but anyhow, guys, I can always, there's a site called, let me just show you, you donate some money. It's called Z Library, né? So you just type Z dash lip, and then you say on the internet, Google, it will take you. You can download some free books there. They ask you to donate maybe $1 or $2 or 5. You can also download without donating. So if they will only give you maybe 3 or 5 downloads a day. If you donate a bit of money, I think with $10 or something, I could download over maybe, I don't know, 50 books in a day or something. So you can download. Some are not very good quality, some are good quality, but just go and look at it. There are quite a number of sites that you can look at. Okay, so guys, Madam Boss has called me. Otherwise, I'll be in trouble. I don't want to sleep on the floor. So good night. We'll see you tomorrow.
Good night, sir. Bye.
Good night, sir.
Okay, bye.
Good night,
Thank
sir.
you. And Happy New Year, guys. I even forgot to wish you all the best. Happy New Year.
Happy New Year,
Sir,
sir.
likewise, sir.
Okay, bye. See you tomorrow at 2 o'clock.
Yes, sir.
Okay, sir.
Okay, bye. Please, guys, those of you that haven't paid yet for January, remind your parents to pay. Otherwise, I'll not allow you to come to school tomorrow if you don't pay. Bye-bye.
Sir.
Yes.
Ask that paid, can we come in what is the schedule?
No, school uniform, please.
Ah.
Because some of you are coming with casual clothes and then you have other turns before you come to classes, or after classes you have other turns. We want you to come to school and go home, please. You can wear any shoes, it's fine, comfortable, like wear your flip-flops or Crocs or whatsoever, as long as you're comfortable. But school uniform, please. If you don't want to wear the official school uniform, you can wear the school, what is this? The golf t-shirt, maybe the tracksuit of the school. That's also okay. That's also a form of school uniform.
Okay, sir.
So bye, guys.
Bye, sir.
All right.
Christmas.
I'll do so.